Hey folks, I am continuing our series on Golang coding on Hackerrank. So let's go. If you like my content, please subscribe. That helps my channel and I really appreciate that. So logging in, come on. Going into the problem solving section. And we're going to go into solve because we haven't covered enough to go into unsolved territories just yet. Unsolved means things that I haven't done yet. All right, easy ones first. And last time we did number 4, very big sum. No, yeah, that's right. And today we're going to do diagonal difference. Let's get into that. Yeah, it didn't save my code from last time, which is great. So what is the problem? They're going to give you an array of a metric. So the number of rows and the number of columns are the same. We have to take the sum of all the numbers in the primary diagonal and then the secondary diagonal. And we have to take the difference and then take the absolute value of it and return that. That's the function we have to write here, right? So everything else is already done for us. We don't have to worry about that. We just have to write that function. Now, how do we do that? How do we first take the sum of the primary diagonal? That's actually pretty easy because the index is whenever the index for the row and the column index is the same. So this is 0, 0, this is 1, 1, this is 2, 2. Then we just take a sum of that. And when we go through a nested loop of going through all the values in the array, as soon as we see the index values for the row and the column are the same, we add them together to come up with the sum of the primary diagonal. Now, the secondary diagonal is a little harder, but there's a pattern to this. The pattern is, you see this, for example, this one right here, the 3. The index for that is 0, comma 2, because it's the 0th row and the second column. In computer science, this is 0, this is 1, this is 2, so it's 0, comma 2. The next one is 1, 1. The last one is 2, comma 0. The pattern here is the sum of the row number and the column number is always 2. And that will be the case no matter how many rows or columns are there. It will always be 1 less than the length of the array. Okay, hopefully that makes sense. So whenever as we traverse through all of the array, if the row number, when we add the row and this column number, if they add up to 1 less than the length of the array, that means that's a number, that's an item on the secondary diagonal, and we add them up and we take the difference. So here we go. So first of all, to make this function work, let's define some variables. First, we define sum primary. It's the sum of, and that will be int 32, and that will be 0 to begin with. Same for sum secondary, again in 32, we will start out at 0. Now we have to traverse through the array. The array is given to us in this variable arr. So for row equals 0, and as long as row is less than the length of the array, it's funny, even if it's a two-dimensional array, length is the same, so which is convenient for us because we can use that function, length of arr. We're good. Then each time we of course increment by 1. Now we have to traverse through a two-dimensional array, we have to do a nested loop. Now we have to say for each row we do a column, we do all the columns. So for column, oh, I forgot to mess that one up. Column equals 0 to start with. Column is less than the length of ARR, and each time we increment by 1. Now we're in the body of one particular item as we go through this. So at the beginning, it will be this 1, then 2, then 3, then 4, 5, and so on and so forth. So we have to now make the condition for the primary and secondary. If row equals column, then let's make a comment, primary diagonal. If row equals column, then we add them up. Sum primary is now added. We add this particular item, the value, primary plus ARR. And this is where Golang is different. In other languages, it's comma. The indexes are comma, but here it's like this. It's row and then column like that. That's in Golang. So now we incremented the sum of the primary diagonal. If row plus column get out of here, column equals length of the array minus 1. Remember, we figured that out when even before we started coding. These are all 2. They all add up to 2, which is 1 less than the length of the array. Okay, row plus column, and then we're in secondary diagonal. Okay. Now we do the same thing as we did for the primary. Sum. Oh, okay, there's a mistake here. We don't need sum, just one sum. Okay. Sum, not from sum. Sum secondary. Yeah, that's why we get there. Okay. Equals sum secondary. I don't know why it does this. Plus this, whatever item we happen to be on, because we're now in the secondary diagonal. Okay, so that should do. Why is it complaining about this? Anyway, we'll deal with that later. So we have the ifs. We're done with the nested for loops. I don't know if you do extra ones or what. This is, oh, that's the for loop. Never mind. So that's the for loop, that's the function, that's the end of function. Okay, so that's the end of for loop. Now, while we're that, now ideally we want to return the absolute value of the difference. But the problem is in Golang, there is no absolute function for integers. We have to make that. So we'll fake that for now. So we'll say return absolute value of sum primary minus sum secondary. Except that we don't have this function yet. So we will write that function. Pretty easy to write. Func abs. It will take in an int 32. Let's call it I, int 32. It will return an int 32. And we will give it a result to begin with. At first, it will just be 0. If I is a negative, that is less than 0, then result equals I times minus 1. If I is greater than or equal to 0, result equals I, and then we return I, return result. Basically the positive value, either way, if it's negative or positive, it will return a positive value. Okay. Oh, not fun, but funk. Okay. No more complaints except this guy. Why is this complaining about that? If row equals column, that's that. This is just a comment. Interesting. Okay. All right, we'll give it a shot, see what happens. Run code. Okay. And line 40 is a problem. Invalid character in line 40. Maybe this has to be the beginning of the line or something. So we will just take it out for now. Yeah, same thing here. So we'll just take it out. Okay, run again. Line 23, cannot use value in type 2. Okay. Doesn't like, maybe you have to put the parentheses. Does that work? Result equals I times -1 in 32. Let's see what happens. Cannot use I minus value of 23 as type int. In 32 is fine. That is interesting. I don't know how to fix that. I in 32. In 32, I should be able to time that -1. I cannot use value of 23 as value is compared to I in 32. Okay. Try this. This one, does that work? Nope. Same problem. Can do that. Nope. Okay. That is a problem. Simple apps function, I equals 0. I is less than 0. Result equals. Oh! I didn't give result a type. Variable result int 32. And still complain about something. Not init, int. Okay, now let's run this. Okay, looks like it worked. Now we run the whole code against unknown test cases. Okay, there you are. It worked for all test cases. Okay, hope you liked the video. Hopefully it's useful, and we will continue doing this kind of coding assignments, because in DevOps interviews, I've seen more and more normal coding assignment, not Terraform or Kubernetes. Of course, they're always there, but some companies test you using normal algorithmic type coding using your favorite language. I will see you in the next video.